everyone to lesson 2.5, families of polynomial functions. Today I promise there will be no explosions, so keep your earphones on. So today we're looking at a group of polynomial functions that have some characteristics in common. To start off, what I'd like you to do on the TI-83 is graph the following functions. So if you need to, you can go to my website and download the TI-83 app and install it. If you don't want to use the TI-83, if you'd like to try something else, there's a program online called GraphCalc that you can download. You can also try Wolfram Alpha. Or Google Graph. So there's lots of options, but I'd like you to take the time right now to graph these 6 different functions so we can compare how they look and how they're behaving. So now you've taken the time to graph those functions. Let's compare the first 3. If we look at my graph, got my 3 functions here plotted, and we can see that even though these 3 functions are different, they're all passing through the same x-intercept. Some are stretched, some are compressed, but they all pass through the same x-intercept. And likewise, if I look at my other 3 functions, I can see that, yes, they're flipped, they're stretched, they're compressed, but again, they're passing through the same x-intercepts. Okay, and I hope you notice the same thing when you graph them. What's happening, what we're seeing, is something called a family of polynomial functions. A family of functions is just a set of functions or a group of functions that share the same characteristics. So polynomial functions that have the same zeros, that have the same x-intercepts, belong to the same family. And the graphs of these functions, we can see that they have the same x-intercept, but if we look back, we can see that they could have different they could have different y-intercepts. An equation, a general equation for these families that have zeros of a1, a2, and so on, would be this. So however many x-intercepts we have, all multiplied by a k value. Okay, some constant that represents a stretch or a compression or maybe a reflection. And the k value has to be an element of the real numbers, and k has to be not equal to 0. So that's what we're working with today. Let's take a look at some questions. So I'd like to represent a function, a family of functions algebraically. I know the zeros of this family of quadratic functions are 2 and 3. So I'd like to determine an equation for this family of functions. So the general form for a family of polynomials, as we saw on the last slide, is this. Now, this is a quadratic function, and it only has 2 x-intercepts. So we'd have our k value, which we haven't specified what it is yet, a factor of x minus 2, and a factor of x plus 3. Okay, and that's the easiest answer for A. Question B, part B, is actually a question that a lot of people have trouble with. I've always found that confusing. Part B is asking us to write equations for 2 functions that belong to this family. So answering this question is as easy as choosing 2 different k values. So I could say that k equals 3. And one of my functions would be 3 times x minus 2 times x minus 3. Or I could pick a different value, negative 7. And then my other member of this family would be negative 7 times x minus 2 times x plus 3. Or, going above and beyond, I can get really creative. I can make my k value equal to pi. And there's another member of this family. Essentially, I need to pick any k value that is a real number, and I would be able to answer this question. Finally, question C, this is where we need to get specific. Determine an equation for the member of this family that passes through the point 1 and 4. You've done this before. We have our k value, which is unknown, and our two factors, x minus 2 and x plus 3. If I'm passing through this point 1 and 4, that means I'm subbing in the values 1 and 4 for x and y. And then I'm solving for k. And I think here I will see that my k value is equal to negative 1. So just a therefore statement, the member of this family would be y equals negative x minus 2 times x plus 3. Okay, our first example was about a quadratic function. Now we can look at a cubic function. So here we have more x-intercepts. But again, if I want to determine members of this family, I have my k value, and I'm multiplying by my 3 x-intercepts. And that's my answer to A. Part B, again, we're looking for equations for any two functions that belong to this family, so I can pick any k value I want, as long as it's a real number. And then I'm answering the question. Where we need to get specific is when we're trying to find an equation that has a specific condition. So in part C, we're being asked to find the equation of a member of this family whose graph has a y-intercept of negative 15. A y-intercept of negative 15 means that the point we're going to sub in will be 0 and negative 15. So I sub negative 15 in for y, and I can sub 0 in for x. So my equation becomes negative 15 equals 6k. So dividing, my k value is negative 15 over 6. We need to reduce that. So I can divide the numerator and denominator by 3, and I end up with negative 5 halves is equal to k. So my equation that satisfies this y-intercept of negative 15 would be y equals negative 5 halves times x minus 1 times x minus 3 times x plus 2. I'd like to give you a little preview of the question that we're going to tackle in class tomorrow. This would be a very good application problem on your test. This question, or questions like this, usually appear on your unit tests. We're finding the equation for a family of quartic functions, but we don't have nice zeros. You can see one of our zeros, or two of our zeros, I should say, is 2 plus or minus the root of 3. Okay. You can try this on your own. In fact, this would be some good homework for you to try on your own. See if you can get it, and I will be doing this question, this exact question, in class tomorrow. So to wrap up, we looked today at families of functions. There's functions that have the same characteristics. Specifically, they have the same x-intercepts. These families have this general form, and our task is to take this general form and apply it to our specific x-intercepts, specific k values, to find those specific members of the family. Okay, thanks for watching. See you in class.